All right, Team Impact here. Let me get situated here. If I can find my mouse over here on this other deal. Okay, there we go. All right. Good morning, afternoon, whatever you want to call it. We're going to get into surface area of nets today. Found out yesterday a net is where we take a three-dimensional figure and lay it flat to a two-dimensional flat object, right? So we're going to find the surface area of these things today. And we're going to go. Surface area is the total covering on the faces of a three-dimensional object. It is measured in square units. Okay, so an example of surface area would be, painting and wrapping Christmas presents, something like that. Okay, and I guess I could do that just to kind of give you an idea there. Decompose the net into shapes and complete the table to determine the total surface area of the rectangular prism. Label each face of the net with the area to visualize it. Okay, so let's go. Formula we're going to use on all three of these since they're rectangles is area is base times height. So let's write that in right now. Okay, and let's plug in some values. Okay, so when we look at this thing, we can break this down a lot of different ways. We have three shapes in here. Okay, and let's call this shape 1 and this shape 1 because they're congruent, right? So we need to decompose this. So we're going to find out that the base is 15 and we need this height. Well, it's not 3. We have to bring that 8 up. So it's 15 and 8. Okay. So 15 times 8 is 120. What I'm going to do is just write 120 in both of those. Okay. That way I have a visual aspect of it. I can always revert back to it. I'll label it at the end. Okay. And when we bring it down there. All right. Now, the next one up is going to be figure 2 or figure B, whatever you want to call it, doesn't matter. All right, let's call this figure 2, shape 2. All right, so we need this piece right here. Well, when we get this piece right here, we're going to find out that, all right, it's actually going to be 3 because this is going to fold up and that's going to fold up. So it's actually going to be 3 meters. So it's 3 times, and then I need the length of it, right, which is bringing that over is 15. 3 times 15 is 45. So we'll call this 45 and this 45. You know what? I'm going to circle those so they jump out. Figure 3 or C, whatever you want to call it, okay, is certainly going to be 8, right? 8 times what? 8 times, well, I need this piece right here. Well, if I look over here, there it is. It's 8 times 3. And that's going to be 24, and that's going to be 24. And I'm going to circle those. Okay, so really 15 times 8 we found was 120. This was 45, and this was 24. All right, so this is a little misleading because this is just for one piece, all right? So really, if you took all of these areas and added them together and doubled it, that would get you there. Or if you just added these circled numbers up, that would get you there. Either way. So what I'm going to do is add those numbers up, and then I'm going to double it. And when I do that, I get 378, okay? And it's in meters, right? And I'm going to label it at the end, square, okay? So what do I notice? What do you notice about the different faces on the rectangle of the prism? What do I notice? That they all have the same formula, all right? It's all the same formula, all right? So not too bad there, right? All right, let's take a look at this next one. This looks to be like a triangular prism down here. And let's take a look at it, right? All right, so for shape 1, all right, I'm going to take, what here? Let's take, all right, we got to look at this thing here. Let's take our triangles. Let's call this figure A and A, all right? So let's just, and I'm not going to write in there because I don't have enough room, but the formula I know is 1/2 the base times the height. And let's plug in our values, right? 1/2 times the base of 3 times the height of 4. Okay, 3 times 4 is 12. Half of 12 is 6. All right, and that's going to be 6. And I'm going to leave me a little space in there so I can double those at the end. Okay, so I've taken care of these two shapes here. Shape A, we'll call these two. They're done. Okay, and I'm going to put a little 6 in there just so I see it. All right. Let's take a look at this one. Okay, so now on this triangle, it's not an equilateral triangle. So we have three separate rectangles here. So let's take care of this one here, and let's just call this 7 times 5. We know it's base times height, right? And it's 7 times 5, which is 35. We only have one of those. I don't need to double that. I'm actually going to go back and double this, so we've taken care of both of these. So that was 35. The bottom piece here, I've got to be careful. Well, this, all right, is area is base times height. This is 4, okay? And then we've got to figure this out. So we've got to actually bring that 7 over, right? 7 times 4 is 28, right? And I'll write 28 in there, just so I see it. And then the front, if we folded this up on this triangular prism, so I need this piece right there, which is actually going to be what, guys? When that folds up, it's actually 3, right? So area is base times height. It's going to be 3, right? Times what? Again, I'm going to go back to that 7. 3 times 7 is 21. Okay. So now if I add these 4 numbers together, right? And when I add those 4, I'm not going to get a calculator out for time purposes, but certainly we could do that. And I should write 21 in there, right? When you add those 4 numbers up, you end up with 96, and it's in centimeters square. Okay. So we've decomposed this. We've broke it down. We've kind of carried things through and looked at it here. Okay. All right. Not too bad so far, huh? Let's take a look at the next one. All right, looks like we have another triangular prism. And if you want, you could pause the video and kind of do it on your own. It's up to you. Excuse me, I had to get a drink of coffee. Decompose the net into shapes and complete the table to determine the total surface area of the triangular prism. Label each face of the net with the area to visualize it. Okay, good. All right, first up, we really just have, this is a little bit different. And I'll tell you why this is a little bit different. This triangle here is an equilateral triangle. So we really just have 2 shapes. These rectangles are all congruent. And that's why we need to understand what our triangles are, because when it's an equilateral, that tells us the rectangles are the same. So let's start with our triangles. 1/2 the base times the height. Let's plug in our values. 1/2 times the base. The base is clearly 8 times the height of 7. Okay. And 8 times 7 is 56. Half of 56 is 28. I know there's 2 of them, right? I know there's 2 of them. So I'm going to multiply that by 2 and go back to 56. So if you wanted to, you could write your 28s in here. All right, and let's go. Now, the next shape is area is base times height, is our rectangles here, okay? So it's going to be 11.2, right? And we need this piece. Well, if I look up there, there it is, times 8. And then, actually, guys, there's what? 1, 2, there's 3 of them. So I'm going to multiply that by 3 here in just a few minutes. But 11 2/10 times 8 is 89 6/10. And I'm going to multiply that by 3. Okay, and I am going to have to grab my calculator on that one. All right, so when I multiply that by 3, and I'm going to turn it on, 89.6 times 3 is 268 8/10, right? So what that gives us is the area of this rectangle, and this rectangle. Now I'm just going to add those 2 together. And when I do that, I end up with 324 8/10, and I believe that's in meters, one to check, square, and circle it, okay? Not too bad, right? Identify your triangle when they're bases, and then that will help you. It will save you time, all right? Very good. Very good. Let's continue on. We're going to decompose this net, all right, and find the area, all right, of the rectangular pyramid. And remember, a pyramid's identified by its base, right? And there's a rectangle formula. Okay, so it looks like we have three different shapes here. So let's start with the easy one, the base. And that's going to be area's base times height. And that's 10 times 6, right? And that's 60. All right, so there's just one. We've kind of taken care of that. Now, if we look at our triangles, all right, we're going to have two here that are congruent, and these two are going to be congruent. So the formulas are going to be the same. We're just going to have different values for our base and our height, okay? All right, so let's go. So this is going to be 1/2 times the base of 6, right, times the height of 9, right? And there's two of them, so I'll double it down here, right? 6 times 9 is 54. Half of 54 is 27, right? But since there's two, I'm going to go back to it. So it's 27 times 2 is 54. Excellent. Next one, so we've taken care of kind of this one and this one, right? Well, let's take care of these two. 1/2 times the base. Well, the base is clearly 10, right? 10, right? And we need the height here, right? And there's the perpendicular mark, 10 times 8. So you can kind of see where I got my numbers from. If we wanted to paint this or wrap it or cover it in some kind of substance, this is what we're looking for, is total surface area. 10 times 8 is 80. Half of 80 is 40. But again, I'm going to go back because there's two of them, right? There's two of them. And go back to 80. Now, if I add these three numbers up, let's see if we can do this with without a calculator here and try to use our mentals a little bit. 80 and 60 is 140. 140 and 54 is 194 inches dot square. Okay, so we just added these three values. Okay, very good. Very good. Okay, so we doing okay? Not too bad. We're just decomposing it and rolling with it. All right, last one here. Janelle found the surface area of the pyramid below. Describe Janelle's error and correct the mistake. Okay, all right. Well, let's go. So we have a square pyramid. So that means all sides are 12 on this, right? So let's take a look at this. 12 times 12 is 144. She's in good shape there, Janelle. Yeah, so that's okay. Now, what I've noticed is if this is a square pyramid, if we found the area of one of these triangles and then just multiplied it by 4, that would give us the total area of all the triangles. So let's see what's going on over here. 1 had 12 times 8. All right, let's see here. 12 times 8, I think, is 96, right? And if we divide that by 2, we get 48. Okay, so here's the problem. 48 is the value of that triangle, but we have how many? 4. So if we take 48 times 4, we're going to get the correct value of the total surface area, which is 192. Now, if we add the 192 and the 144 together, the 192 plus the 144, we're going to end up with 336 centimeters, square. So the problem was they didn't quadruple this. They didn't multiply that by 4, and that's what we needed to do right there. So that was a common mistake. You get in a hurry sometimes. You find the area 1, you get excited, and then you say, oh, well, what's going on? I got to multiply that by 4. These are all equilateral triangles, which means that all sides are equal, and each angle is 60 degrees, okay, because there's 180 degrees in a triangle. All right, so good lesson, more surface area. If we flip the page, you'll see your homework is here. You have 4 of them. Please do a good job with this. Break it down just like we did. If you need scratch paper, certainly use that. Okay? All right, guys, have a good day. Get after it. Let me see if I can hit the